Good morning, students. Up to last lecture, we have studied about some electronic component. Okay, some electronic component and their uses. Okay, so now today we have to see next topic, that is the conductors and insulators. What? Conductors and insulators. Okay, so now in our day-to-day life, we see many substances. Okay, so in which among them many substances, if we think about that substances on the view of electric conductivity, okay, then we have see that some electric wire, okay, so inside that electric wire we see some copper wires are there, okay, lots of copper wires are there and one insulating plastic cover present on that wire. Okay, so that electric wire that is conducting. Okay, we see iron is also electrically conducting. Okay, so generally some substances, if we see, then we are understood that some substances are electrically conducting. And now if we see some substances, okay, as like plastic, wood, cloth, okay, so these are the some substances that we are see that electricity does not pass through that substance. Okay, so means generally we observe all the substances, from that one thing we understood, all the substances are not electrically conducting. Among them some are conduct electric current and some are not conduct electric current. Okay, so on the basis of that electric conductivity, substances are categorized or divided here into two types. Okay, but actually on the basis of electrical conductivity, generally substances are divided into three groups. Okay, first of all, conductor, insulator and semiconductors. Okay, but here in our book we have to study only two type of substances. Okay, so that are nothing but the conductors and insulators. Okay, on the base of conductivity we can divide these substances, all the substances, into two categories. Actually there are three categories, but in our book there are two type of categorization is given there. First is conductors and second is insulators. So in conductors, what happen? Okay, why we have to call them conductor? Because those substances have very low resistance. Okay, we studied last topic, that is the resistance. What resistance do actually? Resistance try to resist or stop flow of electric current. Okay, so here in such a substances, conductors, what happen? That resistance is very low, and we know if a resistance is very low, then charges can easily move. Okay, so in conductors, what happen? Resistance is very low. Also, due to the low resistance, what happen? Electric current can easily flow through these substances. Okay, we know resistance, what do? Resistance try to oppose motion of charges. Okay, so now due to that low resistance present in some substances, what happen? Electric current can very easily pass through those substances. Okay, so this is happen actually inside the conductors. What happen? That is the resistance play important role here to decide conductivity. Okay, if resistance is very low, then charges can move very easily. Okay, means if resistance is low, then conductivity is high, and if resistance is high, then conductivity low. Okay, so in case of conductors, what happen? That substances actually have very low resistance, and due to that low resistance, what happen? Electric current can easily flow through these substances. That is why they are called as a conductors. Okay, and second type is insulators. Okay, so in insulator, what happen? Those substances have very high resistance. Okay, these substances have very high resistance. Okay, so due to the high resistance, what happen? We are actually see when the collisions of moving electrons are takes place with the what atom and ions. What happen? The hindrance in the motion of electron takes place. Due to that hindrance, what happen? They are actually move in various direction. Due to what happen? Resistance is produced there and value of electric current decrease. So in insulator, what happen? There is again very high electric resistance is there. Okay, due to that high resistance, what happen? Charges are not moved from one point to another point because it is not possible to charges overcome this resistance. Okay, so due to that current cannot flow through the insulators. Okay, so that is the very basic difference between conductors and insulators. Okay, in conductors, what happen? Resistance is very low, and in insulator, what happen? Resistance is very high. Okay, so due to the low resistance, what happen? Current easily flow, and in insulator, what happen? Due to the high resistance, current cannot flow. Example here, copper, gold, etc. That are the some example of conductor, and here wood, plastic, cloth, that are the example of insulators. Okay, so these are the two types of substances we can divide on the basis of conductivity. Okay, that is the conductor and insulator. If resistance is very low and electric current is easily passed, then these substances are called as a conductors. And if electric resistance is very high and current cannot flow through that substances, then such substances are called as a what? Insulator. Okay, so that is about the conductors and insulators. Okay, now next topic we have to see, that is the system of resistors and effective resistance. Okay, so actually system of resistance means what? It means that we can connect these resistors in different ways. Okay, so and what will be the effective resistance? If you connect two or more resistors in different way. Okay, different systems, simply we use word here system. So if you connect two or more resistors in a circuit at a time, okay, at that time, what will about that effective resistance of that all resistors, that we have to see in this topic. Okay, so now first of all, there are two ways by using which we can connect resistors in different way. Okay, so here first of all is resistors in series. Okay, means we make connection of resistors in series, that is called as a series connection of resistors. And another one way, that is the parallel connection of resistors. Okay, what? Series connection of resistors and parallel connection of resistors. Both connection we can use in the electrical circuit. Okay, so now here first we have to see resistors in series. Okay, so in series resistance, what happen? All the given resistors are connected in straight line. Okay, in single line, then such a connection of resistors is called as a resistors in series. What? Series means what? Along straight line. Okay, if all resistors are connected in straight line, then such resistance connections are called as a series connection. So here if you see this CD two terminals of this circuit. Okay, so in between these CD terminals R1, R2 and R3, these three resistors are connected on this straight line CD. Okay, so this is a CD terminal in between resistor R1, R2 and R3 are connected in series. Okay, that you have to remember. Okay, so in a series connection, what happen? Generally you have to remember one thing, that value of current, okay, I, in series arrangement what happen, the same current flow through each resistors, okay. In series connection what happen, same current is flow through each resistors, value of current remains same across each and each resistors. That thing you have to remember in series connection, value of current is remain same. Next, value of current and potential different, okay. Suppose we say same current is flowing through each resistors and we say that current is how much, I is the current flow through all the three resistors, okay, and total potential difference between these C and D terminals is what, V, okay. V is a potential difference across terminals C and D, okay. So due to these three resistors what happen, this total V potential difference is divided into the three parts, okay. Suppose this is R1 resistor, across this R1 resistor potential difference is V1, okay. So here across R1 potential difference is V1, across R2 potential difference is V2, and across R3 potential difference is V3. But we know the potential difference between these terminals is what, V, is how much, V. So we can say that this V is equal to this potential difference V1 plus this potential difference V2 plus this potential difference V3. So combination of V1, V2, V3 is nothing but the potential difference between these two terminals, and that is nothing but the how much, V. So we can say that this V will be equal to V1 plus V2 plus V3. Now we have to use Ohm's law, okay. We know according to Ohm's law, we know V is equal to IR, that we studied in the 8th standard, okay. So according to Ohm's law, V is equal to IR, potential difference V is equal to current into resistance, okay. But now here we know I is the same current flowing through each resistor, okay, and value of resistor is different, R1, R2 and R3. Then across first resistor R1, what will be the potential difference? Across this resistor R2, what will be the potential difference? And across resistor R3, what will be the potential difference? That we have to find out, okay. So we can say that V1 is a potential difference across resistor R1, V2 is a potential difference across resistor R2, and V3 is a potential difference across resistor R3. So by using Ohm's law, we can say that this V1 is equal to I into R, okay. But this is the V1 is the potential difference across resistor R1. So we can say that V1 is equal to I into R1. Same way, across resistor R2, what will be the potential difference? That is the V2, okay. Current is the same, current remains same everywhere, value of resistor is changed, okay. So across resistor R2, V2 be the potential difference, okay, and according to Ohm's law, how much that potential difference? I into R2, okay. Across same way, this third resistor R3, what will be the potential difference? That will be the V3, okay. Current is same I, but resistance is how much? R3. So V3 will be equal to I R3, okay. That is the potential difference across each resistor, okay. So we know that all potential difference, V is equal to V1, V2, V3. V1 is equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. We called it equation number 1 and put all this value in equation number 1. Means instead of this V1, we have to put I1 R1. Instead of V2, we have to put I2 R2, and instead of V3, we have to put I R3. Okay. So instead of V, we have to put I into RS. RS what? Because these three resistors are connected in series. Okay. RS means what? Resistance in series. So IRS will be equal to V1 is equal to how much? I1 R1. V2 is equal to I1 R2, and V3 is equal to IR3. Okay. So IR1 IR2 plus IR3. Okay. Here if we take I common from right hand side, then R1 plus R2 plus R3 is remaining. I from both sides get cancelled. So remaining is what? RS. RS means what? Resistance in series. That will be equal to R1 plus R2 plus R3. That is the effective resistance of three resistors when they are connected in series. Okay. So if n number of resistors are connected in series, then their effective resistance of series will be equal to I1 R2 plus up to Rn. Addition of all the resistors we have to takes place. So calculate their effective resistance when they all resistors are connected in series. Okay. So such a way that simply one thing you have to remember, when we are connected all resistors in series. Series means what? In one line. When we are connected all resistors in series, then their effective resistance are nothing but the addition of value of resistors of every resistance. Okay. Suppose these three resistors are connected in series, then their equivalent resistance will be equal to addition of values of each resistors. If n number of resistors are connected in series, then their equivalent resistance will be nothing but the addition of values of n number of resistors. Okay. So such a way that we can calculate the value of resistance when they are connected in series. And when resistors are connected in a series, then their equivalent resistance is nothing but the addition of value of each and every resistance. Okay. So that thing you have to remember. If you have any doubt about this topic, then please ask me in the comment of this video. So the next topic, that is the parallel connection of resistors, that we have to see in tomorrow's lecture. Thank you.